Yes, a disconnecting means must be installed between the power inlet and the transfer switch. According to the National Electrical Code, a disconnecting means must be installed within sight of the generator and within 5 feet of the power inlet. This disconnecting means can be a circuit breaker, fuse switch, or plug-in receptacle combination. The 5-foot rule applies to both manual and automatic transfer switches. The purpose of the disconnecting means is to provide a way to safely disconnect the generator from the electrical system when it is not in use. This is important for safety and maintenance reasons. With the 7,500 watt generator, it exceeds the NEC requirement for disconnecting means to be rated at least 30 amps. Therefore, you will need to install a disconnecting means that is rated for at least 60 amps. When installing the power inlet and disconnecting means, firstly, make sure the wiring is properly sized and protected. Secondly, use a weatherproof enclosure for the disconnecting means. Thirdly, label the disconnecting means clearly so that it is easy to identify. Finally, test the disconnecting means regularly to make sure it is working properly. The National Electrical Code, or NEC, provides specific guidelines regarding the installation of generators and their associated components, including the disconnecting means. These guidelines are in place to ensure safety and proper operation. Article 700.12 of the NEC covers emergency systems, which often involve generators. This section outlines the requirements for the source of power, including generators. It emphasizes the need for the generator to be reliable and capable of supplying power within the required time frame. Article 701 addresses legally required standby systems, which are essential for facilities like hospitals and fire stations. It covers similar aspects as Article 700.12, but with specific requirements tailored to the needs of these critical facilities. Article 702 focuses on optional standby systems, which are not legally required but provide backup power for various reasons. This article provides guidance on the installation and operation of these systems, including the generator and its associated components. Article 445 of the NEC is dedicated to generators. It covers a wide range of topics, including overcurrent protection, wiring methods, and disconnecting means. This article is crucial for understanding the specific requirements for installing generators safely and in compliance with the code. Section 445.12 specifically addresses overcurrent protection. It mandates that generators must be protected against overcurrents, which can damage the equipment and create safety hazards. This section outlines the requirements for fuses, circuit breakers, and other protective devices. Section 445.18 deals with wiring methods. It specifies the types of wiring that are permitted for connecting the generator to the electrical system. This section ensures that the wiring is suitable for the voltage, current, and environmental conditions. Section 445.19 covers the disconnecting means. It requires that generators must have a disconnecting means to isolate them from the electrical system for maintenance and safety purposes. This section specifies the type of disconnecting means that are permitted and their location. The 5-foot rule is often associated with Section 445.19. It generally states that the disconnecting means must be readily accessible and located within 5 feet of the generator or the power inlet. This requirement is in place to ensure that the generator can be quickly and easily disconnected in case of an emergency. The ampacity of the wiring and overcurrent protection for a generator is determined by several factors, including the generator's output rating and the type of load it will be serving. The NEC provides specific guidelines for calculating the ampacity of conductors and the size of overcurrent protection devices. These calculations take into account the continuous nature of generator operation and the need to prevent overheating and damage to the equipment. The disconnecting means for a generator must be rated appropriately for the generator's output. The rating of the disconnecting means must be equal to or greater than the generator's rated current. This ensures that the disconnecting means can safely interrupt the flow of current in the event of a fault or overload. In the context of manual transfer switches, the disconnecting means is typically located near the power inlet as mentioned in the question. This allows for easy disconnection of the generator from the electrical system when it is not in use. The disconnecting means can be a circuit breaker, fuse switch, or other approved device. In the context of automatic transfer switches, the disconnecting means may be integrated into the transfer switch itself. This allows for automatic disconnection of the generator when utility power is restored. The disconnecting means must still be readily accessible and rated appropriately for the generator's output. When installing a generator and its associated components, it is crucial to follow all applicable codes and regulations. The NEC is the primary source of guidance for electrical installations in the United States. Local codes and regulations may also apply, so it is important to check with the local authority having jurisdiction. Proper installation and maintenance of the generator and its disconnecting means are essential for safety and reliability. Regular inspections and testing can help to identify potential problems before they become serious. It is also important to keep the area around the generator clean and free of obstructions to ensure proper ventilation and access. In summary, the NEC provides detailed requirements for the installation of generators and their associated components. The disconnecting means is a critical safety feature that allows for isolation of the generator from the electrical system. The 5-foot rule is a general guideline for the location of the disconnecting means. It is important to follow all applicable codes and regulations to ensure safe and reliable installation. It's also important to understand the difference between grounding and bonding in electrical systems, especially when dealing with generators. Grounding refers to connecting the electrical system to the earth, providing a path for fault current to flow back to the source and trip a circuit breaker or fuse. Bonding, on the other hand, refers to connecting non-current carrying metal parts together to create a low impedance path for fault current. In a generator system, proper grounding and bonding are essential for safety. The generator itself must be properly grounded and all metal enclosures and equipment must be bonded together. This helps to prevent electrical shock hazards and ensures that fault currents can flow safely back to the source. The size of the grounding and bonding conductors must be appropriate for the size of the generator and the electrical system. The NEC provides specific guidelines for determining the proper size of these conductors. It is important to follow these guidelines to ensure that the grounding and bonding system is effective. In addition to grounding and bonding, surge protection is also an important consideration for generator systems. Surges can damage sensitive electronic equipment and create safety hazards. Surge protective devices, or SPDs, can be installed to protect the electrical system from surges. SPD should be installed at the main service entrance and at any other points where surges may enter the system. The selection of SPD should be based on the voltage, current, and surge capacity of the electrical system. It is also important to consider the environmental conditions when selecting SPD. Some SPD are designed for indoor use, while others are designed for outdoor use. The installation of SPD should be performed by a qualified electrician. The electrician will ensure that the SPD are properly grounded and bonded, and that they are connected to the electrical system in accordance with the manufacturer's instructions. Proper maintenance of generator systems is essential for ensuring their reliability and safety. Regular inspection should be performed to check for any signs of wear, damage, or corrosion. The generator should be started and run periodically to ensure that it is in good working order. The oil, filters, and spark plugs should be changed on a regular basis. The battery should be tested and charged as needed. The fuel tank should be kept full and the fuel should be stabilized to prevent degradation. Any repairs or maintenance should be performed by a qualified technician. The technician will have the knowledge and experience to properly diagnose and repair any problems. It is important to keep records of all maintenance and repairs. These records can be used to track the performance of the generator and to identify any potential problems. The records can also be used to document compliance with warranty requirements. In addition to the NEC, there are other standards and regulations that may apply to generator systems. These standards and regulations may address topics such as emissions, noise, and safety. It is important to be familiar with all applicable standards and regulations before installing or operating a generator system. Compliance with these standards and regulations will help to ensure that the generator system is safe, reliable, and environmentally friendly. The installation of a generator can be a complex project. It is important to plan carefully and to follow all applicable codes and regulations. If you are not comfortable performing the installation yourself, it is best to hire a qualified electrician. The electrician will have the knowledge and experience to properly install the generator and to ensure that it is safe and reliable. The electrician can also help you to select the right generator for your needs and to obtain any necessary permits. By following these guidelines, you can ensure that your generator system is installed and operated safely and reliably. This information is for general guidance only and should not be considered as a substitute for professional advice. Always consult with a qualified electrician before installing or operating any electrical equipment. This information does not constitute professional engineering advice. A qualified professional should be consulted for any specific project or application. Proper planning is paramount when installing a generator. Firstly, evaluate your power requirements. Determine the essential appliances and devices you need to run during an outage. Calculate the total wattage required, accounting for both starting and running watts. Secondly, select the right size generator. Choose a generator that can handle the peak load of your essential appliances. It's better to have a generator that's slightly oversized than one that's undersized. Thirdly, determine the location of the generator. Consider factors like ventilation, noise, and proximity to the house. Ensure the generator is placed on a level surface and protected from the elements. Fourthly, obtain the necessary permits. Check with your local building department for permit requirements. Some jurisdictions may require permits for generator installations. Fifthly, hire a qualified electrician. Unless you're experienced with electrical work, it's best to hire a qualified electrician. They can ensure the generator is installed safely and in compliance with local codes. Also, consider a transfer switch. A transfer switch allows you to safely switch between utility power and generator power. It prevents backfeeding, which can be dangerous for utility workers and your neighbors. Next, install the generator according to manufacturer's instructions. Follow the manufacturer's instructions for installation and operation. This will help ensure the generator runs safely and efficiently. Finally, test the generator regularly. Start the generator periodically to ensure it's in good working order. This will also help you familiarize yourself with its operation. Choosing the right type of generator is crucial for meeting your specific power needs. There are several types of generators available, each with its own advantages and disadvantages. Firstly, portable generators are a common choice for homeowners. They are relatively inexpensive and easy to move around. However, they typically have a lower power output than other types of generators. Secondly, inverter generators are known for their clean power output. They are ideal for powering sensitive electronics like computers and smartphones. Thirdly, standby generators are permanently installed and automatically start when the power goes out. They provide a seamless transition to backup power and are a good choice for homeowners who want reliable backup power. Fourthly, diesel generators are known for their durability and fuel efficiency. They are often used in commercial and industrial applications. Lastly, natural gas generators are connected to your natural gas line and provide a continuous supply of fuel. They are a convenient option for homeowners who have access to natural gas. When choosing a generator, consider the following factors. Firstly, power output. Select a generator that can handle the total wattage of your essential appliances. Secondly, fuel type. Choose a fuel type that is readily available and cost-effective. Thirdly, runtime. Determine how long you need the generator to run during an outage. Fourthly, noise level. Consider the noise level of the generator, especially if you live in a residential area. Fifthly, price. Set a budget and choose a generator that fits your needs in your budget. Maintaining a generator properly is essential for ensuring its longevity and reliability. Firstly, change the oil regularly. Follow the manufacturer's recommendations for oil change intervals. Secondly, clean or replace the air filter. A dirty air filter can restrict airflow and reduce engine performance. Thirdly, check the spark plugs. Replace the spark plugs if they are worn or fouled. Fourthly, inspect the fuel lines. Check the fuel lines for leaks or cracks. Fifthly, test the battery. If your generator has an electric start, test the battery regularly. Sixthly, store the generator properly. When not in use, store the generator in a clean, dry place. Seventhly, run the generator periodically. Start the generator periodically to keep the engine lubricated and the fuel fresh. Finally, keep a maintenance log. Keep a record of all maintenance and repairs. The proper use of extension cords is crucial for safety when using a generator. Firstly, use heavy-duty extension cords. Use extension cords that are rated for outdoor use and can handle the amperage of the appliances you are powering. Secondly, avoid overloading extension cords. Don't plug too many appliances into a single extension cord. Thirdly, inspect extension cords regularly. Check extension cords for damage or wear. Fourthly, use ground fault circuit interrupter or GFCI protected extension cords. These cords can help prevent electrical shock. Fifthly, keep extension cords dry. Avoid using extension cords in wet or damp conditions. Sixthly, don't run extension cords under rugs or carpets. This can create a fire hazard. Seventhly, unplug extension cords when not in use. This can help prevent damage to the cords. Lastly, store extension cords properly. When not in use, store extension cords in a cool, dry place. Understanding generator safety is crucial for protecting yourself and your property. Firstly, never operate a generator indoors. Generators produce carbon monoxide, a deadly odorless gas. Secondly, keep the generator away from windows and doors. This will help prevent carbon monoxide from entering your home. Thirdly, install carbon monoxide detectors. Install carbon monoxide detectors in your home to alert you to the presence of the gas. Fourthly, never refuel a generator while it's running. Allow the generator to cool down before refueling. Fifthly, use a funnel when refueling. This will help prevent spills. Sixthly, store fuel safely. Store fuel in a well-ventilated area away from heat sources. Seventhly, never overload the generator. This can damage the generator and create a fire hazard. Lastly, follow the manufacturer's instructions. Follow the manufacturer's instructions for safe operation. The NEC, or National Electrical Code, provides specific guidelines for generator installations. Firstly, Article 700 covers emergency systems. This article outlines the requirements for generators used in emergency situations such as hospitals and fire stations. Secondly, Article 701 covers legally required standby systems. This article outlines the requirements for generators used in legally required standby systems such as schools and nursing homes. Thirdly, Article 702 covers optional standby systems. This article outlines the requirements for generators used in optional standby systems such as homes and businesses. Fourthly, Article 445 covers generators in general. This article covers a wide range of topics, including wiring methods, overcurrent protection, and disconnecting means. Fifthly, Section 445.11 covers marking requirements. This section requires generators to be marked with specific information such as the manufacturer's name, model number, and rated output. Sixthly, Section 445.12 covers overcurrent protection. This section requires generators to be protected against overcurrents. Seventhly, Section 445.13 covers ampacity of conductors. This section specifies the ampacity of conductors used to connect the generator to the electrical system. Lastly, Section 445.14 covers disconnecting means. This section requires generators to have a disconnecting means to isolate them from the electrical system. Using a transfer switch safely is crucial for preventing backfeeding and ensuring a safe transition between utility power and generator power. Firstly, install the transfer switch correctly. Follow the manufacturer's instructions for installation. Secondly, label the circuits clearly. Label the circuits that are connected to the transfer switch. Thirdly, understand the operation of the transfer switch. Familiarize yourself with the different positions of the transfer switch. Fourthly, turn off the main breaker before switching to generator power. This will prevent backfeeding into the utility grid. Fifthly, start the generator before switching to generator power. This will ensure a smooth transition. Sixthly, monitor the generator. Check the generator's voltage and frequency to ensure it's operating properly. Seventhly, switch back to utility power when power is restored. Turn off the generator before switching back to utility power. Lastly, test the transfer switch regularly. Test the transfer switch periodically to ensure it's working properly. Determining the right size generator for your home requires careful consideration of your power needs. Firstly, make a list of essential appliances. Identify the appliances and devices you need to run during an outage. Secondly, determine the wattage of each appliance. Look for the wattage rating on the appliance label or in the owner's manual. Thirdly, calculate the total running wattage. Add up the wattage of all the appliances you want to run simultaneously. Fourthly, determine the starting wattage of each appliance. Some appliances, like refrigerators and air conditioners, require extra power to start. Fifthly, calculate the total starting wattage. Add up the starting wattage of all the appliances you want to start simultaneously. Sixthly, choose a generator with sufficient capacity. Select a generator that can handle both the total running wattage and the total starting wattage. Seventhly, consider future needs. Choose a generator that can accommodate your future power needs. Lastly, consult with a qualified electrician. They can help you determine the right size generator for your home. Understanding generator maintenance schedules is crucial for ensuring the longevity and reliability of your generator. Firstly, daily checks include checking the oil level, checking the coolant level if applicable, and checking for any leaks or damage. Secondly, weekly checks include starting the generator and letting it run for a short period, checking the battery voltage, and checking the air filter. Thirdly, monthly checks include cleaning the generator enclosure, inspecting the fuel lines and connections, and checking the spark plugs. Fourthly, annual maintenance includes changing the oil and filter, changing the air filter, replacing the spark plugs, and inspecting the fuel system. Fifthly, every 2 years, have a qualified technician inspect the generator, check the engine compression, and perform a load bank test. Sixthly, every 5 years, replace the fuel lines and hoses, replace the battery, and have the generator professionally serviced. Seventhly, keep a maintenance log. Record all maintenance and repairs performed on the generator. Lastly, follow the manufacturer's recommendations. Follow the manufacturer's recommendations for maintenance intervals and procedures. Properly grounding a generator is essential for safety. Firstly, locate the grounding terminal. Find the grounding terminal on the generator. Secondly, connect a grounding wire. Connect a grounding wire from the grounding terminal to a grounding rod. Thirdly, drive the grounding rod into the ground. Drive the grounding rod at least 8 feet into the ground. Fourthly, use a copper grounding rod. Use a copper grounding rod that is at least 1/2 inch in diameter. Fifthly, ensure the grounding wire is properly sized. Use a grounding wire that is sized according to the NEC. Sixthly, protect the grounding wire from damage. Protect the grounding wire from physical damage. Seventhly, test the grounding connection. Test the grounding connection to ensure it's properly grounded. Lastly, consult with a qualified electrician. Consult with a qualified electrician if you have any questions about grounding your generator. Choosing the right location for your generator is crucial for safety and convenience. Firstly, choose a well-ventilated area. Generators produce carbon monoxide, so it's important to place the generator in a well-ventilated area. Secondly, keep the generator away from windows and doors. This will help prevent carbon monoxide from entering your home. Thirdly, place the generator on a level surface. This will help prevent the generator from tipping over. Fourthly, protect the generator from the elements. Use a generator cover or enclosure to protect the generator from rain, snow, and sun. Fifthly, keep the generator away from flammable materials. Keep the generator away from gasoline, propane, and other flammable materials. Sixthly, ensure easy access for maintenance. Place the generator in a location that allows easy access for maintenance. Seventhly, consider the noise level. Place the generator in a location where the noise won't disturb your neighbors. Lastly, check local regulations. Check local regulations for any restrictions on generator placement.